We're beginning a section where we're dividing polynomial expressions. So we've seen polynomials already, done a lot with them. They're the smooth continuous curves where they have only x's of different degrees. Well, now we're going to try to divide them. And although this book, I really appreciate OpenStax, especially being free, but when it gets to some of the topics, it's a little thin on examples. So I'm going to try to mention some of the stuff that's not here, and if I need to make some supplemental videos with some specific problems, I'll do that. But the idea is this. It's going to follow long division, exactly like we did when we were a kid. So if I were trying to divide, I'm going to show you this process. You probably remember this, but if you don't, you might be a little rusty here. I'm going to take 5 and try to divide it into 2, and I can't, so I'm going to go 5 into 24. Now that would go 4 times is the best I can do. Now what I would do next is 4 times 5 is 20. Now you check for leftovers by subtracting to see what you didn't have enough for. We had 4 left. Okay, now do you remember what we did next? We would bring down the next number and we'd play again. I'm trying to get 5 into 49. Okay, well I could do that by doing a 9. Now 9 times 5 is 45. So I would have a remainder of 4. That is exactly how we do this game here. Exactly. So higher math is just following principles of easier math that you already know. So we're going to set this up like this. We're going to divide 5x squared plus 3x minus 2. We're going to divide it by x plus 1. Now this process is confusing for people, so hang with me here. What we want to do is we want to get this first letter, this I don't know, to turn into 5x squared. What can we multiply by to turn this in to 5x squared? Well, it would be 5x. Now, what's different here is we're going to check for the remainders. We're going to multiply this out, but it's 5x not just times x, it's 5x times x plus 1. So we have to distribute this. We have to send the 5x to both. So another way to think of it is just when you're dividing at 5x times x and 5x times 1. You got to do both. Okay, so we multiply those, we get 5x squared. 5x plus 1 is plus 5x. Now, if you're going to struggle, this is where it's going to go wrong. It isn't terribly hard, but we now have to check for those remainders. And before we made this negative 20, and that was easy. We just saw that we subtract, we get 4. But here we're doing a polynomial, a binomial, and subtracting. So this negative sign has to go to every one that follows. So some people will go back through and change all the signs literally on their paper, erase it, and put the new signs. I do it like this, but I have to remember that these signs are changing. So just that's where you got to be careful. So if you did it right, this first term should always cancel. These are now opposites, and so this is really negative 5x squared, so they are. Now this negative is then down here, so this is not 5x, it's negative 5x. So if I check for my leftovers, I get negative 2x. Bring down the next number. Now, just like we did over here, we're going to play the game again. This time I want to turn x into negative 2x. Okay, we'll do that with a negative 2. Okay, negative 2 times all of this. It's like the distributive property. I'd get negative 2x minus 2. Now, when we check for our leftovers, because we're subtracting, all these signs will change, and there is no remainder. So when we divide these, we get 5x minus 2. Okay, again, there are not a ton of examples here, and I'm going to try to mention any of the oddities that you might see. But let's do it again. Okay, now we're trying to turn this first one, 3x, into 6x to the third. So to do that, we would need 2x squared. So let's check. 2x squared times 3x squared, that's right, 6x to the third. 2x squared minus 2x minus 4x squared. Now, We check for our leftovers. This changes every sign that follows. So this is now negative 6x to the third, and that's right, it would go away. This now is positive 4x, so it's not opposites. I actually have 8x to the second. Bring down the next one so we can play again. Okay, I want to turn 3x into 8x squared. Is this right? Hold on. I'm surprised by that. Oh, sorry. Here's what happened. This I can read my own writing. That's an 11. Okay. I was like, that isn't going to work. So this was 11x squared. So when I subtract these, I get, I'm going to start this line over, 15x squared minus 31x. So that was positive 11. This negative turned that to positive 4. So I've got 15x squared. Okay, now we can get it to work. 3x into 15x squared. I would need a 5x. Now this times this is 15x squared. 5x and negative 2 is negative 10x. Okay, let's check for leftovers. That's changing every sign. So these are gone. This is now a plus 10x. So we're going to have negative 21x. Bring down another number. Okay, how do I turn 3x into negative 21x? Minus 7 would do that. So let's multiply negative 7. That gets me negative 21x. Negative 7 times negative 2 is plus 14. Okay, check for leftovers. We're going to have something we haven't seen yet. So these are gone. It's really a positive 21. This is negative 14. Get a remainder of 1. Now, the idea that we're going to show here next is really the same thing we did. Do you remember if I had an improper fraction? What I would do to turn it to a mixed number is I would divide 4 into 9, and I'd get 2. But I'd have a leftover. I'd have 1. And what I would do is I would put it back over that 4, which I divided by, and it'd become 2 and 1/4. That's what we do in advanced math when we divide these polynomials. This remainder of 1, we're going to say, okay, plus 1 over the binomial that I divided by. 1 over 3x minus 2. So this is how I would write my answer, and I have that remainder tacked on to the end as a fraction. Okay, now I really recommend you pause the video and try this because again there aren't very many examples, so really recommend that. I'm going to get started here. Okay, we need to turn this first one into 16x to the third, and the way I would do that is 4x squared. This times this, 16x to the third. Now I got to do it times both, so 4x squared times 5 gets me 20x squared. Checking for my leftovers, this is gone now. It's really a minus 16. This is now negative 20. So I have negative 32x squared. Bring down the next one. Okay, once again, we're going to play again, but I got to turn 4x into negative 32x squared. So I've got negative 8x would do that. Okay, multiply these. I've got negative 32x squared. Negative 8 times 5, negative 40x. Check for my leftovers. Okay, this is gone. This is now plus 40. So I've got 60x. Bring down my negative 3. Okay, so one more time. We're going 4x into 60x. That's going to be 15. So 15 times 5, 75. I did it in the other order. I shouldn't have. 15 times 4x is 60x. 15 times 5 is 75. Okay, check for our leftovers. The 60x's are gone. I've got negative 75 and negative 3, so I get negative 78. Okay, now here's how we write. Now, we've seen this before. If you have a fraction, negative 5, 6, you could put that negative sign in the front, you could put it up top, you could put it on the bottom. It doesn't matter where you move it. And so we're going to, instead of writing addition, because it's negative 78, I'm going to write negative, or subtraction, 78 over 4x plus 5 for my remainder. Okay, now let me talk about some exceptions. This says synthetic division. I took this from a different slide. The next way, there's two ways to do this. We'll talk about synthetic division in the next one, but there are all kinds of exceptions that you could see. And the most important idea is this. You must have placeholders if you don't have all of the degrees all the way down to 0. So what I mean is this. Do you notice here I have x to the fourth, I have x to the third, but I don't have any x to the seconds? Well, if you're missing any, you have to add a placeholder. I'm going to add 0x to the second. Now we'll work this one in a minute, but suppose I had been dividing by this, x squared plus 7. We could do that. But if we did, we would have needed to add a placeholder. So anytime you're missing a degree as you go down the polynomial, you have to add placeholders. So let's do this one. I'll show you what I mean. So again, it says synthetic division. We're not doing that. We're doing long division, just like you did when you were a kid. So I'm adding 0x to the second as a placeholder because there weren't any. And be careful, if you miss this, it'll mess you up. So don't forget. So on a test, you'll get messed up by not catching the missing placeholder. Okay, so I'm going x into 3x to the fourth. So 3x to the third would do that. So 3x to the third times both of those gets me 21x to the third. Check for my leftovers. This is really negative 21x to the third now. Okay, now let's make this front end go into this one. So that would be negative 3x squared to make that happen. So I get negative 3x to the third minus 21x squared. Okay, check for leftovers, changes all the signs. Now see, I have my placeholder here, and this just becomes 21x to the second. Okay, I had my placeholder, I've used it up, so now we're going to use minus 3x. Now x into 21x to the second would be 21x. Just make sure 147. Okay, check for leftovers again. What do I have now? Negative 150. My handwriting is terrible. Negative 150x. We're going to bring down that 40. Okay, we're going to get a huge number here. So x into negative 150 is negative 150. So that's how I turn these guys into each other. So I've got negative 150x. Busting out the calculator for this one. $10.50. Okay, check for leftovers. Alright, so that's gone, and I would have positive 1050, so I've got positive 1090. Now that's a remainder, so I'm going to add it here over what I divided by. So I don't know if it's worth writing this again, but I will. And you will see remainders this large. It's not that all that uncommon. Now, I'm out of slides here, but so I wish I had a little space. You can see one other variation. So again, let me say this again so you don't miss this. The placeholder thing is essential. So whether it's what you're dividing into or dividing by, if there is a missing term as you go down, you need to add the placeholder. The other thing I was going to just say is you can divide by 3 terms as well. Suppose we had divided this thing by 3x squared plus 2x plus 1. You can do that. We would then just be dividing 3 steps into the first 3 places. Does that make sense? Same process. We'd still match up the front ends. We would then just be multiplying 3x times all 3 items. So suppose it would be this. So when we did our top, we would go x squared times each of the three pieces. I don't know if that's making sense. That's not a common thing that I would probably put on a test, but you can see that. The bigger deal is just know that straight process. It follows long division from elementary school exactly, and don't forget the placeholders.